and again with number 6. So in this case, we have the second derivative of x plus 4x, that looks familiar from our first problem we did, is equal to the cosine of t times the, not times, x of 0 equals 0. And also we're told that the first derivative evaluated at 0 is also 0. So one thing I want to make sure that we understand here is it can be tempting because of the fact that we have this x squared plus 4x, and we've seen that before, right? We saw that in our first problem before. And it can be tempting to say, well, I already know what that is, and write down that solution. And that is true in some part, except for the fact that don't forget, if your initial conditions are different, the end result is going to be slightly different. So you have to make sure what's happening with your initial conditions. So let's do this. Laplace transform of x, the second derivative. We already found this part. That's s squared times f of s minus s to the first times lowercase f of 0 minus f of first derivative of 0. That's that transform. And if I switch this to x's, I'd have s squared of x minus s times f of 0. And f of 0 would be x of 0, so this would be 0 minus 0. So all of this part would be s squared times x. Then the Laplace transform of 4x is going to be 4 times the Laplace transform of x. So this is 4 times x, so this is s to the 0 times capital F of s, which is equal to 4 times x. So then we have the other side is Laplace transform of cosine of t equals, and I have to look at my table to figure out what the Laplace transform of cosine of t is. So that would be s over s squared plus kt. And in this case, k is equal to 1, so s over s squared plus 1. So when I put that all together after my Laplace transforms, I have s squared times x plus 4x is, let me make this a little nicer here, plus 4x is equal to s over s squared plus 1. And so if I solve this for x, I get x and s squared plus 4 is equal to s over s squared plus 1. And that is equal to x is equal to s over s squared plus 1 divided by s squared plus 4. So that would be s over s squared plus 1 times s squared plus 4. Okay, so how we have to figure out the inverse Laplace transform of this is to do partial fraction decomposition. Okay, so let's do that. So I have an s over s squared plus 1. This is an irreducible or non-factorable quadratic. And then s squared plus 4, which also is a non-factorable quadratic. So I'm going to set that equal to, and I can never remember how many terms I'm supposed to put on the top. But I'm going to do as I almost put x because I'm used to putting x, but as plus b over s squared plus 1 plus abcs plus d over s squared plus 4. So I'll be honest with you, I'm not 100% sure that I need these other terms, the b and the d. But, as a rule of thumb, I always sort of try and think of, well, if I overshoot and I added too many terms, because I have I have this squared here. If I overshoot and I put 2 terms because I have a squared, and as it turns out I don't need that b, when I solve this, I'll end up getting b equals 0, and I'll end up getting d equals 0. So if I don't need them, then that's okay. Now, some people would say that's kind of a waste of time. I should memorize the chart, but I don't have the chart memorized. So I just know I have a squared thing on the bottom, so put 2 terms on the top. And as it turns out, if the second term needs to go away, if I didn't really need that term, and it'll be equal to 0, and that's okay. So anyways, let's solve this. So I have s is equal to the quantity as plus b times s squared plus 4 plus the quantity cs plus d times s squared plus 1. And then I need to solve that system. And let's see here. I have s is equal to s cubed times a. So s cubed times a plus 4a times s plus s squared times b plus 4b plus s cubed times c plus cs, and then plus s squared times d plus d. And so I have s equals s cubed times the quantity a. So I take that one out and this one out, a plus c, plus s squared times b plus d. Take this one out, plus s times 4a. So take this one out, and plus c. Take that one out, plus s to the 0 times 4b plus d. Okay, so this means I have this system a plus c equals 0, and b plus d equals 0, and 4a plus c equals 1. So here is an s, and here is an s. So that's 4a plus c equals 1. And then I have 4b plus d equals 0. So this is my system of equations. And because I'm comfortable with matrix algebra, I'm going to write this as 1, 0, 1, 0, 0. And 0, put the 0 in the wrong spot. 0, 1, 0, 1, 0. So this is a plus the top row is a plus 0 plus c, right? Plus 0 equals 0. That's what the top row means. And the second row means 0 plus b plus d. That's what the top row means, right? So then for the next row, I have 4 times a, 0, 1, a, b, c, 0, and then 1. And then 0, 4, 0, 1, 0. And this is my system. And I put that system into reduced row echelon form. And when I got that, I ended up with the system. Let me copy it down here. 1, 0, 0, 0, a third, and then 0, 1, 0, 0, 0, and 0, 0, 1, 0, minus 1 third, and 0, 0, 0, 1, 0. That was my system that I ended up with. So that means that A should equal 1 third, and ABC should equal minus 1 third. Okay, so that means that I have S over S squared plus 1 times S squared plus 4 is equal to, way up here, I had this A, and I guess as it turns out, I didn't need the B, and I didn't need the D, but I couldn't remember at the time. So then I have 1 third times S over S squared plus 1, and then minus 1 third times S over S squared plus 4. So I could write that as 1 third times S over S squared plus 1 minus 1 third times S over S squared plus 4. I could write it that way. And again, all of this was this capital X of S. So then when I do the Laplace inverse of this, of X of S, I have to figure out what the Laplace transforms for each of these two things are. And so when I look on my table, I see that S over S squared plus 1 is cosine, where k is equal to 1. So this is 1 third cosine of kt, where k is equal to 1, so times t, and then minus 1 third, and this would be cosine of 2t. And so that is my Laplace transform. So this would be lowercase x of t equals, and I suppose I could factor out the 1 third, so I'd have cosine of t minus cosine of 2t all divided by 3. And that is my solution.